All right, welcome to another Emerald Hill Skies live stream. We're broadcasting here from the outskirts of Louisville, Kentucky. And we've just done our autofocus, and look at that beautiful hyperbole. Hyperbole, is that right? Hyperbola. Yeah, hyperbola. It's almost a perfect curve, and our focus is settled on focus stopping point 30,195. So we're ready to head back up to equipment and stop the focuser in Nina, and then head over to the camera, stop the camera in Nina, and then close Nina and open up SharpCap. How about that? While that's opening, I'll get the I'll try to get the live stream going on my phone here so I can monitor along with you. Yep, there we go. I'm going to make sure we have audio going. Monitor along with you. Okay, so there we have audio. And this was an unannounced live stream because honestly we didn't know what the weather would be like. It's a beautifully clear night, though, and so we're excited to also tell you that the mount connected perfectly the first time. And, of course, that's as it should be, right? But if you've been following along in these last couple of weeks, you know that we've not had exactly the greatest relationship with our mount. And on Sunday night's live stream, we discovered why. So we're pretty excited to be able to get started. There you see a live picture from SharpCap. That's a live shot through the telescope of Polaris. Here's Polaris right here. And this is the imaging software we use. Is called SharpCap, and that's pretty much the standard bearer, along with another kind of sister program in the ASI Air world. But SharpCap is an imaging program that allows you to take pictures through your telescope and then show them to you live. And not only one picture, but we can stack multiple pictures. They call it live stacking. And in the lower right-hand corner of the screen, you see a picture of the scope. I'm going to also see if we can get you a picture of the camera that's riding on top the scope. There it is. You can also see the glare from the sun. Sun, not sun. The glare from the moon. The moon's about 86 or 87% tonight. So that's pretty bright. And so there's a lot of moonlight. The camera that you see taking pictures of the scope, that is actually a WISE 3, like a surveillance camera. And it is, let's see if I can get that out in front. There we go. It's going to show you a picture of the tri-pier that iOptron makes for this scope, and also the iOptron mount here. It's a CEM70G. And on top of that is an 11-inch RASA, the Roe Ackerman-Schmidt astrograph. It's a special scope that's made specifically for imaging, and the camera actually mounts in front of the scope. There's no eyepiece. So that's what we're seeing the images through tonight, that 11-inch RASA. And let's get going then. Let's see, I think we're ready to go. We're going to start up our Planetarium program. We've just switched over the last couple of weeks to a new program called Starry Night Pro. I'm kind of excited about this. You guys who know me well, you know that I am excited. I don't know why it's been so much fun to discover this. I guess I should call it rediscover it, because I have used Starry Night Pro a couple times in my life. But the idea of rediscovering it, it's been just a lot of fun. I'm going to see if I can get it configured here so that when we're looking at it, we're seeing a pretty good size image of it. Why don't we do it sort of like this? So when we're looking at Starry Night Pro, we can see it pretty good size. Let's see, that shouldn't get in the way of the scope view. Or when you open up Starry Night Pro, you have the choice of opening up a Starry Night Pro preferences file, and I have that configured. So here we are, and this horizon is pretty much exactly configured to match our horizon here at Emerald Hills. You can see that we're looking at as we open up Starry Night Pro, you can see we're also looking at Polaris. That's it right there in the middle. What we're going to do now is try to connect to the scope, and we do that up here, show telescope setup, and we're going to try to connect. And there it is. Wow, we're connected to the scope, so that's a good thing. And you know, the other night we used this really cool feature. Let me see if we can do that tonight. Telescope control was called Follow the Scope, and I kind of liked it because whatever the telescope was pointing at, we were seeing what the telescope was looking at here through Starry Night Pro. So I think now we can close that little applet. And look here right on the screen, it says here iOptron SIM 12070, you know, and it's actually showing you that right there is what we're looking at. Now, this is a field of view indicator for Starry Night Pro. I think when we zoom in, that field of view indicator might actually align with what the scope is pointing to. That's exactly what happened. So you can see now we're looking at exactly at the North Pole, which by the way is not pointing, the North Pole doesn't precisely point at Polaris. This is telling us that this is looking exactly at the North Pole. We've already polar aligned, and our red rectangle here is our field of view of our RASA telescope. So wow, we're ready to go, ready to roll. Now I've looked at some targets that we can use tonight, and I called the targeting list Christmas Cluster Globs and Christmas Cluster Opens. Open stands for Open Cluster. So let's start, since we started with the Christmas Cluster Globs this past Sunday night, let's start with Christmas Cluster Opens tonight. And you can see the first one on the list there is the Christmas Tree Cluster. And let's just show info on it for a second. And you can see it rose at 6:40 p.m. and it transits at 1:15 a.m. So it should be well up in the sky by now. So this is a good safe object to look at. We don't have any log entries on this. We have never viewed the Christmas tree cluster, I guess. So let's go there. How about that? So why don't we close this back down and let's right click here. I'm always nervous when we go to the first object because what if things aren't going to work correctly, you know? But let's try it. We're going to say center. It's not going to let us do that, is it? Because we want to slew to Christmas tree cluster. That's what we want to do. Because our gaze of Starry Night Pro, now take a look at your, watch your telescope slew there, because it will, in the lower right hand corner, you'll see the scope move. Is my image kind of hiding the telescope a little bit? It is, isn't it? We need to refresh our, there we go. It needed to refresh a little bit. And you can see Starry Night Pro is kind of following what the scope is looking at. And there's a Christmas tree cluster. I'm going to go over to the little software that we use here to to let you look with me, and I'm going to try to reposition the scope view a little bit. Let me just go to the scope cam thing here. I'm going to bring that. I guess there's not a lot more to see there. And then I'm going to go to the screen, kind of try to position that so you're getting the most that you can out of that. And then so that my silly picture here is hiding the, so that I'm hiding as little of the screen as I can. Wow, that messed things up, didn't it? There we go. How about that? Is that a little better? Something like that. Now, let's go back to, well, let's first look here. And I think what will happen is when we zoom in, I think our field of view, oh, we might need to do a little bit of syncing since this is our first target. Let's go back to SharpCap and let's do what we call a plate solve. Now, a plate solve is designed to help the telescope compare what it is seeing through its real-time imagery with a database of pictures of the sky. And when it does that, it finds a way to align them. And you can see we were up here at the top in this little green bar. It tells us we were 1.76 degrees off, but that's because this is our first target. And the very first thing that we look at, that plate solving technology synchronizes the computer that's built into that scope. It synchronizes that computer with the computer and the imagery that we're using here in a kind of a ninja magical way so that it meshes the two views. And then it enters, when you sync that, it enters that learning, like artificial intelligence, into the model that the scope uses to point to the next object. And with each object you go to and point to, it gets that much more accurate. And you'll see as the night goes on. So here we are. This is at a 25% zoom. Let's kind of back off and look at the big picture here. So this is the Christmas tree cluster. And we're supposed to be able to see a Christmas tree here. Are you seeing it yet? I'm not exactly seeing it. Are you? We're supposed to be shaped like a Christmas tree. Let's go back over to Starry Night Pro. Now you see how when we synced, it aligned that red rectangle that shows our field of view. It aligned that with the actual cluster. Now let's zoom in a bit here and let's see if we can kind of see the cluster doesn't look a lot like a Christmas tree, does it? It looks a little bit like a Christmas tree, maybe. I guess that's supposed to be the star on top. And look, there is some nebulosity here. You know, when we use the word nebulosity, it means this cloudiness that we see. And that's probably because this cluster is shining through a cloud of dust. And so let's go back to our SharpCap and let's live stack this image a little bit. So we've already aligned. Why don't we, to get that nebulosity and really pull it in, let's go with something like 20 seconds. And let's change our gain to something like 100 gain. And we'll wait down here in the lower right-hand corner. I don't know if you can see it. We might have it covered up with a bunch of these. Yeah, my picture might be covering up. It shows a green bar graph of the image coming in. And that enables us to see how the image looks. So that's a pretty good exposure. So now let's make sure we put in here the name of this object. And I'm just going to go back over here and look at it. With Starry Night Pro, you have to minimize the thing in front of it. The Christmas tree cluster, let's right-click and show info here. I like to use the NGC number when there's no Messier number attached. And sure enough, there's not a Messier number. So this is NGC 2264. let's go back over to SharpCap, NGC 2264. Let's get rid of that. NGC 2264. And let's start live stacking. Now, live stacking, like I say, what we're going to do is take a 20-second exposure of this part of the sky. And while we're taking this exposure, the mount is aiming the scope at the sky as the Earth rotates. And you can kind of think of it as the mount sort of like freezes the sky in a way. And that's because the mount is tracking with the stars as they appear to move across the sky. And we all know that it's really the Earth rotating, but the stars appear to move across the sky. So the mount is actually tracking with those stars now. That's kind of one of the magical things that happens here. And so what we're doing is we're taking a picture, 20 seconds, a 20-second image, and then with each image that we take, we're stacking the image on top. By the way, if you're looking at the stream tonight, we'd love it if you would maybe say hello in the comments there if you'd like. It's up to you. You don't have to, but we'd love it if you would want to say hello as you log on. So what happens then is as these pictures are stacked in the computer's brain, one on top of the other, what happens is the image gets a little bit better with each picture. And what we can do down here, let's go over here on the side panel, and we're going to reset that display histogram on the side panel. And then we're going to come here, and we're going to reset this big histogram at the bottom, and we'll do an auto stretch, they call it. That gets us close. And then we'll do a reset of the color and then do a white balance auto stretch. You can see how our blues were a little bit out of whack. Now let's grab this black level bar here. And let's bring it over to make the sky a little bit darker. And what we like to do is we like to set that black level just barely to the right of that peak. Then what we do is we bring these mids in and we kind of scrunch those together. And what that does, we call this stretching the histogram. I don't know why we call it stretching, because it actually looks like we're bringing the two bars closer together, doesn't it? But that's the term that you hear used sometime. Now, as we're doing this, I don't know if you're noticing, let's zoom in a little bit on this image. Right now we're at the full camera view, which is pretty wide. Let's get the exact format. It's 6,248 by 4176 pixels. So 6248 by 4176. It's pretty wide. They call this APS-C format on this ASI 2600MC Pro APS-C camera. We're going to zoom in now, and when we say we're zooming in, we're really just looking more closely at the camera's pixels. We're not actually changing anything on the scope. This is all done with the actual camera. So now you're starting to see some of this nebulosity here. And that's the nebulosity. Now let's go back to Starry Night Pro so you can see this nebulosity here is what we're starting to see. Now, maybe if your particular color perception is picking up on the fact that color doesn't match, does it? And colors in the sky are really hard to predict because what you have is the fact that we don't really see colors very well in the night sky when we're looking through an eyepiece. So these colors are all kind of tricking us, aren't they? So what we try to do is we just try to simulate this the best we can. Let's zoom in a little more, and we can adjust these colors a little bit, but actually I think that's not bad, because what we see in the Christmas tree cluster is a lot of younger stars that are bright and blue. they're newer, relatively newer stars, and they're shining through this cloud of dust. And the reason why the dust is bluish here, I think, is because the stars are blue. Let's go back over to Starry Night Pro. Sometimes when you're going to Starry Night Pro, you have to minimize the program in front of it. And let's bring up the info screen about the Christmas tree cluster, and let's just look at it. It says it's a very large, bright cluster with an associated diffuse nebula. It was discovered by astronomer William Herschel. The cluster is visible to the unaided eye as a fuzzy patch. Binoculars reveal 20 of its brightest members, with many fainter ones in the background. This grouping of stars is arranged in a triangular shape, reminiscent of a Christmas tree, for which this cluster is popularly named. A 6th magnitude star punctuates the top of the tree, I guess where the star would be. And NGC 2264 is embedded in nebulosity, which may be detected with a large telescope under dark skies. We do not have dark skies tonight. This moon is 86% illuminating the whole sky. And the city of Louisville is Bortle 5-6 range. What that means is a scale that we use to talk about light pollution. It means pretty light polluted. So the city of Louisville has given us a light dome for us to look at tonight. But in spite of that, by using EAA, Electronically Assisted Astronomy, we're able to kind of pierce through that light dome. We also use a filter to help us out. And the filter is a Celestron light pollution filter made for the RASA 11. I should say optimized for the RASA 11 itself. So that's what's helping us get this nebulosity as well. To the south of the Christmas tree cluster lies the Cone Nebula, a remarkable object in the long exposure photographs, but difficult to detect visually. The Cone Nebula and the Christmas tree cluster are both part of a larger star-forming region. So there we see the position of the sky. I'm just going to check here under more. There is an audio description. I wonder if I could try to play that, if you can hear it. I'm going to try it. Can't hear it yet, can we? Wonder what we have to do to play that. Let's open up our sound settings and let's see which mixer that might be playing through. Oh, it says you are hearing it. So I'm going to get my headphones. Okay, so odds are you were hearing that, but I wasn't, because I didn't have my earbuds in. Let's go back to that again and play that again. There we go. All right, so there you go. Now, this is an open cluster, and he was comparing it to the age of globular clusters. We looked at a number of globular clusters Sunday night, and as you heard him say, those are said to have an apparent age of 10 million years or so. This is a very young cluster, and maybe only just an apparent age of about 1 million years. And these stars are flying through space pretty rapidly, whereas the globular clusters we looked at on Sunday night were flying kind of slowly. So we're going to go back to the live image, and let's see if we can do just any better bringing some more of that nebulosity in. Let's do another there we go. Let's push that just a little bit. I think on a night when we have a lot of moon, it doesn't hurt to bring this down a little bit, but okay, let's try to identify. You know what, the Christmas tree, you might be looking at it upside down, you think? Let's see. Yeah, there we go. See, this would be the star, and that's the left side of the tree, and this is the right side of the tree. So let's zoom in a little more so you can see a little better. Yeah, so you kind of got to cock your head. That's the left side of the tree, and that's the right side of the tree. So this would be kind of like the bottom. That's like the tree trunk. And then this is that nebula that the Starry Night Pro narrator was talking about that's down here at the bottom. And that nebula has a separate name. It's called the Cone Nebula. So tell you what we're going to do. We're going to go back to Starry Night Pro. You have to minimize the program in front of Starry Night Pro. And we're going to right-click on Christmas Tree Cluster and say a new observation. And this is our first observation. We're going to say associate an observing list with this. And the observing list is the Christmas cluster opens. And then we're going to, this session's been given a name, and it's just calling it Untitled Session for now. That's okay. We'll title it later. And here we're going to say, nice view of these bright blue young stars. We could easily make out the nebulosity even with, what is it tonight, 86% moon. Let's get that moon exactly, because I want to make sure that we are giving you the right facts here. 86%, yeah. So here we go. Even with an 86% moon, let's see. We could also see the Cone Nebula below the Christmas tree. Beautiful Christmas image. Now this image is called the Christmas tree cluster all year long. But isn't it great that we can observe it here? And you just close that. Isn't it great that we can observe it on the 22nd of Christmas, 22nd of December, so that you can get the enjoyment of the full view? Let's take a picture of this, the whole screen, but let's also take a close-up. I'm trying to figure out how could we'll worry about rotating the picture later. Right now I think I'll take a screenshot of this, and I'll just try to get this part, and later on we'll maybe turn it around. Boy, I like to get all of this, because there's nebulosity down there to the right too. And let's call this I'd like to give it the same name we use in SharpCap, NGC2264. So we're gonna save as. We're gonna put this in desktop in the SharpCap captures, and we're gonna call it NGC2264 screenshot on 2021-12-22. That should do it. And then later, what I might do is I can actually post that in the night sky of the Planetarium Program, Starry Night Pro, and kind of put our image up there. And I think that'll be fun. We can do that later. So I think we're all done here. Let's zoom out to full APS-C format and just look at it one more time in all of its full beauty. And look at this major star field, all this rich star field going on. It's really a beautiful cluster, and it's fun to have you here enjoying it with us.